Keeping rules for today. Okay, housekeeping. Well, welcome to everyone who's here. Recording the materials. This session is being recorded. Slides and materials will be shared after the webinar. You can drop questions in the chat at any time, but we'll also have dedicated Q&A sections. And if you have any issues, you can message me in the chat, or you can always try leaving and joining again. Next slide, please. So today's trainings are brought to you by South Coast Air Quality Management, part of their Go Zero program. And they're brought to you in partnership with the Energy Coalition and Electrify My Home. And these trainings offer industry-aligned training, flexible training formats, and workforce development. Next one. And today's webinar trainer is Larry Waters from Electrify My Home, and he'll introduce himself a little bit more. And yeah, I hope everyone has learned a lot today.
All right, great, great. All right, so good morning, everybody. Thank you for joining us on this fine Thursday morning. Um, if you haven't joined us before, we're gonna hit a lot of stuff today, get into some really good conversation. First, we'll do the introduction on why zoning. I'm going to give you a little background on what we're doing and some ducted zoning tips with ducted systems, predominantly how we do them and the reason why we do them that way. And we'll go over ductless multi-zone overview and a case study, and then we'll talk about a multi-zone ducted system case study and how that came out. Okay. So the big question is why, what are the things that make people want to do zoning? And if you've been in the HVAC industry any time at all, you know two-story houses have problems. Big houses with ductwork that goes all the way out to the end have problems. And customers always have the idea of like, oh, I want to have a thermostat in each room or whatever. And we have to be realistic and understand how this is done. So why do people like the idea? There's perceived improved comfort. Sometimes there's actual improved comfort. And most of the time, when we put some dual zone control system in a house that has the ductwork set up in a way that we can move the air back and forth, has kind of always been the solution. Upstairs needs heat or cool, or upstairs needs cooling. We can just run the upstairs, not the downstairs. That whole thing, we've all done that. Um, we also perceive that that's going to create energy efficiency, and the details and the kind of the data on that doesn't really play that out. We'll talk a little bit more about that. So um, we think we're going to get an efficiency gain. We think we're going to save a little bit of money, and we perceive that this solution is going to be pretty reasonable at a reasonable price. And it is on a lot of systems, like traditional unitary systems can benefit from zoning as long as the machine can operate with and still stay at capacity and give us decent performance when it's only running on the smallest zone, which makes the problem happen. But what are some of the reasons? We got some houses that are hot upstairs and warm downstairs or cool downstairs. That's the biggest thing is the two-story houses, the big houses with the separate wings. I mean, you just look at that house. That one's going to be hard to condition, right? It's going to be hard to get even airflow through that house, no matter how tight your design is. So unique architecture is another good reason. Sections of homes seldom used, like if the kids have moved out and it's just the parents living in the house now potentially, and they got the empty nest, and they don't want to keep that nest conditioned necessarily if it is not going to be efficiently beneficial. And sometimes it isn't efficiently beneficial. Sometimes it makes more sense just to condition those spaces, even though people don't want to condition them. So we have to have that conversation. And then we've got the age old, the domestic temperature battles. Um, my house is opposite of this right now. My wife really likes it cold in the house. And, since I'm married and I love my wife and I want to stay married, I just get a blanket. So that is what it is. We do what we do what we need for each other. So when it comes to heat pumps, it's a little bit different. So if I've got a dual zone control system on say a two-stage air conditioner and a two-stage furnace, and I can lay that system out where it's half the house for each stage, and I'm going to be at 60% operating capacity on low and 100% on high. We can kind of make that work pretty easily. It's going to be okay. One zone closes, it pops back down into low stage. We've got some sort of control over it. Heat pumps are way different. Heat pumps, when we're running heating mode in a heat pump, if we don't have enough airflow, we're going to cause the heat pump to go out on high pressure and high temperature. If we do that with a furnace, it's just going to be a limit switch is going to open temporarily. The furnace is going to cool down, the burner will relight, and people will not even know that that's going on for years, right? But with a heat pump, it's going to cause major problems. Because that unit will shut off, and some of them are going to shut off until somebody comes back and pushes that button for that high pressure relief. So it can present a really a big problem. We need to be careful with it. And inverter heat pumps have helped with that a bit. And then multi-zone technology has helped a bit. But we got to be really careful with multi-zone. We'll get into that details about that. But what we found is that with heat pump zoning, multiple dedicated systems work so much better. So we're going to share the reasons why that is. And then we have variable refrigerant flow. These are great because they have a really low turn down rate and they don't need to share refrigerant with the other circuits. So they have the best chance at real zoning, but these things are really expensive and way more difficult to install, and they're pretty difficult to install on an existing home, like a retrofit scenario. And then we got the traditional zoning with control boards and automated dampers, and some of these inverter heat pump technology companies have got um, zone controls that work with their communication algorithms, but they're not always that successful with it. And then we got these things called smart vents, and you see these on. I've been seeing these up on the HVAC and the heat pump Reddit page recently as kind of a solution. You put a thermostat in one room, it runs off of a battery. The little damper in the grill has a battery in it, and it just communicates when that house or when that room reaches, it just shuts the vent off, which is, okay if you've got a balanced system. If you've already got a system that's got high static pressure and you start shutting off registers, that can be the breaking point of when that unit is no longer going to work properly and we start wasting a lot of energy and not getting the job done. And sometimes it's just better to keep those rooms conditioned. We'll talk about that for a minute too. Customers are finding these things online, and they can obviously cause noise. Anytime we shut off airflow at the end of the duct, all the air has already got there. So it's going to try to sneak through the things, which is another reason why dampers are so much better because they're going to be upline and they'll be closer to the system. So there's at least going to be less noise and it can redirect the air down through the other ductwork better rather than sending it down there and having it stop at the end and building up a bunch of pressure in the duct and then having to overcome that pressure and then go into the others. If we shut the damper right off at the plenum, all the air is going to go right down through there. So we save tons of energy not pressurizing that extra duct. Um, and then you know, it's not an insane solution, but it's going to have a backward compatibility problem. I don't know if any of you guys have seen these new registers that they have that you can put on the wall and you kind of put the mud around them and they look like they're part of the wall. Those things are terrible too because they don't have any air, they cut the airflow too much. They look beautiful. So that means all those houses where we're dealing with um with designers are going to want those because they're beautiful and they're going to cause problems with the system, no different than just stopping the air anywhere else in the system. Ducted zoning, if you're going to do ducted zoning, there's some things we need to be mindful of. Um, we need to keep our static pressure in our systems at a reasonable number so that we can, one, not take out the motors. Almost all the systems that are coming out now have ECM motors, electronic communicating motors, ECM motors. Those motors are not designed for high static pressure. And so when we have high static pressure over time, it can cause those motors to overheat. And then we start changing motors in systems. And that's because we install systems that are operating outside the preferred range of static pressure. Now there is some conversation about what does it mean if I have a system that has ultra low static pressure? So that can be a problem too because we can't build up the velocity and everything else we need in that system to do that. So the effects is delivered. It affects delivered airflow, system performance, efficiency, noise, equipment strain. Undersized ducts can cause this problem. Dirty filters, blocked registers, long or restrictive duct runs, or multiple zone controlling systems. And for the ducted zoning to work properly, we have to keep these numbers in check. Some of the systems that are out there now, there's a EWC system that we've installed a few of. They work pretty good. Um, Pretty good is where I want to just say pretty good. They will actually monitor the static pressure and they will open the secondary damper a little bit to relieve pressure as needed to keep it kind of in the sweet spot. But then we've moved air to the other zone that may not need conditioning. So um, there's always going to be trade-offs. You just need to have to understand what the trade-offs are and design around them. Okay. Zoning doesn't fix bad ductwork. If I have bad ductwork in the house and or um a bunch of small ducts coming off the system, the that's going to be a net negative benefit because we've already got high static pressure in the system, and then we're going to add zones to it. It's going to make it even worse. So, um, high static pressure, lower delivered airflow. Man, we see stuff all the time that's just crazy. Like this is a duct system with a bunch of home runs in it, and and there's a bunch of dampers in this system. Like there's one here on this duct here, there's one here, one here. They're just everywhere. So when we have all these small ducts, when we blow that plenum into smaller ducts and we don't use a large duct to transition into the smaller ones, there's a ton of takeoff resistance. In other words, all those start collars have like a 35-foot equivalent length. Just by the time the air gets into that start collar, it's already the equivalent of 35 feet of duct. Now, if I put a damper in there, which is going to cause static pressure, even if it's open, there's not going to be a lot, it's not going to be zero. It's not going to be crazy impactful. But when we do it on a system like this with a bunch of trunk lines, we're already squeezing the air into a bunch of small spaces. And then we're going to shut off these dampers in little areas. So a better way to do this would be to put two maybe 16-inch dampers feeding into a pressure plenum that has the other ductwork coming off, or a graduated Y branch duct system so that the air can smoothly move through there and we don't have all that resistance at the beginning. If you think about it, if I've got one 16-inch start collar, I have one place where there's a 35-foot reduction. If I've got a bunch of home runs coming off of that plenum, I've got each one of those has 35 feet of length before it ever gets out of the plenum and into the duct. So major difference. And then we get this sort of thing, like, you know, try to think about and explain how this got done. This is like 4 o'clock in the afternoon. I lost my knife on the other side of the attic. We realized one of the ducts wasn't connected right before we were going to leave. Something happened here that caused this to be the case. It could be just a complete lack of training, a lack of caring, a lack of understanding that my relationship with the customer should include doing the best job I can. But this is real life. I found this on a job site. So, in order to compensate for high static pressure, we've had some pretty crazy ideas over time. And one of them was a return air bypass. So you find systems out there that still have this. And yes, a bunch of them are uninsulated in the attic space. But what is the problem with putting one of these in. One is a, a company I worked at back years ago. They did tons of zoning systems with single stage units and put these bypass dampers in. It was all the choices we had before two stage was a thing. And then we'd get the guy go out and sell a zone system on an existing single stage system. And then we got to put dampers on everything. We got to put this thing in. And all this is doing is it's letting the conditioned air return back to the return plenum. The systems are not designed to do that. If I'm in the cooling mode on here, I shut a couple of these vents or these dampers here. I build up enough pressure to open this to compensate or to push against that weighted rod that's going to open it up. So I built up enough pressure. My damper starts to open. It's in air conditioning mode. I've got nice, warm, 75-degree air coming into the return. I blow it through the system. I bring it across the coil. I now have 55-degree air ish going into this plenum if my static pressure is right. And then I'm going to blow 55-degree air back into the return. That's going to lower my return air temperature dramatically, which could drop the coil temperature below freezing. And that's the system. That's the problem we saw with these things all the time. They still cause the unit to freeze up because the return air temperature got so cold. And in the summer, or excuse me, the winter time when you're running the furnace, it was even worse. Um, we got 45-degree heat rise here. We got 60, let's say 60, 105-degree air coming through this, or 70 degrees, 115-degree air coming through this system. I'm going to close a couple of dampers because the upstairs has gotten hot now. And now I'm only blowing air downstairs. I've got enough pressure in this duct to overcome the balance weight here. I've opened this. And now I've got 115-degree air going into my return plenum. This thing is still going to try to do a 45-degree heat rise. Now I've got a mixture of 70-degree air and 140-degree air. And it's going to keep getting worse as it goes because I'm delivering all this hot air back into the plenum. This thing is just going to keep getting hotter and hotter and hotter. And that means I could potentially be blowing air down these ducts that's 130, 140, 150 degrees. And that's going to cause the limit switch in the furnace to open. Limit switches in furnaces will open, they will cool down and close again until they don't. And then you get that call like, oh, it's blowing cold air. We go out, we don't understand why the limit switch is bad. We can just go, oh, we got a bad limit switch. It's a bad part. Limit switches don't go bad, they just don't stop open. They're a normally closed device. If they ever went bad, they just wouldn't open. So it had to open somehow and not close back up. And it did that because the spring lost so much pressure in there from opening and closing so many times. But our customers never felt that because there was so much hot air coming out of here that by the time the fan in the furnace cooled down that limit switch, they still had nice warm air coming into the house. They literally did not know it's cycling on the limit switch. And those limit switches are supposed to open and close like 20,000 times before they go bad. So if that's happening and the limit switch goes out, we got to figure out why the limit switch went out. And if you see one of these, you know why, right? So we don't like to bypass air. In fact, they've made this illegal in California. And now, kind of, the protocol is on a system like this, we would need this to be a two-stage system. And we would need each side of the duct system with one side open or one side closed, or upstairs open, downstairs closed, whatever. They need to be able to produce 350 CFM per ton out of either side. So really the only way we can do that, if we want to run a system that can actually heat and cool the whole house at one time, we need to have a stage system. So we need a stage zone board so that when one zone closes, it operates off percentage of zones and just goes back into low stage for heating and cooling. And so what we see a lot of times is there's two-stage furnaces in the house, but there's not a two-stage air conditioner. So we're still blowing full capacity in cooling mode, but just not in heating mode. So you got to think this stuff through when we do this and make sure that it's going to work for the customer. We need to put a system in that works, not just one that works for our commissions, right? So does it save energy? Well, the answer is just like everything else. Sometimes it does. There was a study done well, there's a bunch of studies done by all these different groups, and they found that Like this one looked at a 5 degree setup or down in each zone for part of the day with a basement. Their energy costs for heating went up 148% or went up to 148% of normal. Um, 5% set down in each zone as part of the day with the basement. The cooling cost was down a bit, or the cooling energy. And so that was great. Heating energy went up. What is this one? 135 for no temperature setup. So we didn't change the temperature. We just ran the zoning control. Bill went up to 135%. No temperature setup, 121%. 10-degree difference in temperature during the day. Heat went down a little bit. But are we doing that? Are we taking the time to think about that? ASHRAE is showing like central with no modulation, an 8 hour, 12-degree setback zoned with modulating furnace and two additional setback periods on bedroom zones. Hey, that's great. The thing still went up like a lot. Central with no modulation, 8 hour, 12% zinc with modulating furnace and 22 hours of setback on bedroom zones. The power went down a little bit. A good rule of thumb is if we are going to be heating and cooling an area that hasn't been heated and cooled effectively before, it's going to use more energy to do that because we're taking care of a load that we weren't dealing with before. So if the unit is now just going to run upstairs to take care of the cooling upstairs, they used to be hot, now they're cool, the bills are going to go up. Okay. So the challenges with heat pump systems, and we talked about this a second ago, but single and dual stage heat pumps are the similar challenges with AC units. If you have a dual stage heat pump and you set the thing up on a zoning system, it's going to be better than if you put it on a single stage or some inverter systems, because inverter systems are not designed to do this. And what we've seen a lot, and I've seen it because other customers have showed me the quotes, is people putting in a system that is a communicating system. They put in 24-volt control interface modules, so the thing like runs on 24 volts, and it basically takes all the communication out of the thermostat, and then they run that through zoning. That still does not do it. Now we've got three things in there that aren't talking to each other instead of just two. So pressure and refrigerant sensing inverters are probably less problematic. So like your Bosches and GEs and some of the AC Pro stuff and some of the Bryant stuff and some of the Medea, some of those units work off of temperature control and not like communication. And basically if we're blowing air across the coil and we've got a full amount of airflow and we have a predictable amount of coil temperature because I've got low static pressure and the thing is running like it's supposed to, that unit can bounce all the way up to high speed if it needs to. And as the coil gets colder, which means the house is getting colder if I've got perfect airflow, that unit will slow down. That is not a bad solution with zoning because you're just going to make that refrigerant artificially cooler by slowing down some of the airflow. So that will slow the outdoor unit down, but most of those units come with a single speed ECM blower motor, which the zoning can take out the blower motor. Now, maybe the unit's going to transition between stages, but we're going to be using blower motors. Communicating inverters have thousands of points of communication in there. They will move small increments based on the temperature inside, outside, and what the thermostat is telling it. So there's a communication algorithm that's going in there. Those are not designed to have traditional zoning installed on them because that traditional zoning is not communicating with the system, and the system's going, it's starting to get all these weird false readings and unpredictable readings in the algorithm. Like it sees, wow, it's really hot outside. I've got some temperature coming back in my return air, but my coil, my supply temperature is really low. It throws the whole thing out of whack, and that can cause like mystery fault codes and things like that. But there are some companies that are working with these. One of them is AirZone, the other one's EWC, the two that I've seen actually work with these manufacturers because those zone control companies have gotten the algorithmic communication language from these units and they can interact with the unit. So they can tell the unit to slow the fan speed down and kind of work with that by communicating with it like it was the thermostat. But what we're seeing is not that. We're seeing 24-volt controllers put on these, which kind of dumbs the system down in the first place, and then putting zoning on it. And it just freaks the systems out. They don't know what to do with it. And it causes all kinds of problems. Now I got a customer that paid a premium price for a premium system, and somebody cut it off at the knees and made it so it doesn't work right. So be careful, careful, careful with that. Ductless zoning must be done very carefully as well. So, and what I'm talking about is multi-zone mini split systems are very particular, and there's an issue that exists with these. So these are pretty good with the zone boxes or the branch boxes. They're going to be potentially a little better, but we're setting ourselves up for a lot of problems with these because we don't want to just think about what is the true comfort that's been brought to us through the system. We also want to think what is the cost to the customer. And now with copper at an all-time high price and vinyl line cap at an all-time high price, this can get very expensive to install very quickly. There's a lot of pieces of equipment. Multi-zone outdoor units are considerably more expensive than single-zone outdoor units. And then we have the BTU sharing issue. So if I'm going to go put, let's just say we're going to put 5 wall mounts in a 3 bedroom house. We're going to put one in each bedroom. We're going to put two in the living spaces. I have to add up the capacity of all of these heads in order to match it to the outdoor unit. So if I've got some of the manufacturers, the heads go as low as 6,000 BTUs. Some of them only go down to 9,000 BTUs. What we found by doing hundreds and hundreds and hundreds of load calculations is that bedrooms don't need 6,000 BTUs most of the time. Maybe on the coldest and hottest days of the year, they might need that if it's not already cool inside, but they only need that for a few minutes while they bring the air temperature up or down. Once they once they need to slow down and modulate and give you the effective benefit of a modulating system, they can't slow down far enough. So if I've got 5 of these in here, I've got 3 6s, which is 18s, and this say we have 2 12s. So 24 plus 18 is 36. I can get a 36,000 BTU unit that I can do this with. Well, if I do a load calc on the house and that house only needs 18,000 BTUs, I'm already putting a system on the house that's double what it actually needs if I just took care of it with really good ductwork. So then we have the other problem, which is the larger these systems get, the higher the minimum BTU rating is. So these things can only slow down so far because they need to have oil returned back to the system. So if I've got a system here that'll only slow down to 20,000 BTUs, and I've told that customer, oh, this is a great idea because you got room by room temperature control, and that customer is thinking in his head, great, I can just run the master bedroom and I don't have to heat and cool the rest of my house. They get an idea that this is going to be a super efficient way of doing it. However, in reality, what happens is I've got a 6,000 running in one room, or I got that problematic room where the daughter is up in the front corner of the house where it's got the southwestern exposure and it's on 2 walls. Whatever. I've got that one room that wants to run all the time. This unit can only slow down to 18 or 20,000. I've got a 6,000 BTU unit going here. It's always going to put out 6,000 BTUs. It's never going to go less than that. In fact, it might overclock a bit. And then that extra refrigerant, because this thing can't slow down that far, is going to be fed into the next units in the channels. So if I've got multiple channels on the outside of here, or I got multiple channels here, if I can't get all the capacity I need out of the first channel, it's going to send refrigerant into the next channel. So which means I've got a unit in another room that is either getting hot or cold, but the fan isn't running because they don't have it, it's not calling for heating or cooling. And then I've got to go to a third one potentially. So now I've got refrigerant flowing through 3 units in the summertime. That means that coil is going to get cold, and that cold coil up in the corner of the room is going to start to sweat even though it's not running, and that can create problems with humidity in the room and kind of the funky or the funky sock smell. Doing it in the heating mode can create a whole different set of problems. Like I got this thing that's producing heat up in the corner, even though I don't want heat up in the corner because I got it turned off. And then you're going to get the expansion and contraction sounds from the plastic. and then just all kinds of like little issues. So the best way if you're going to do this is not go with one big outdoor unit. It's maybe break it up into two smaller units. Maybe you want to do a 24 with the two 12s and do an 18 with the three nines or the three sixes. And then I've got a much lower turn down rate, and that reduces that problem. Because if I'm trying to get efficiency and I'm saying I can run one unit at a time, it's only 6,000 BTUs, but my machine is really can only slow down to 20. I'm paying for 20,000 BTUs, but I only need a fraction of six. So just be careful with these. Ducted is always going to be more efficient if you do a good job. And it's going to cost less. So here's the other problem with these. I've got, say, three of these. So we'll just say 5 units. I've got 5 line sets. I've got 2 connections on the end of both line sets. So I've got 4 connections on each line set. That's 20 connections that could possibly leak. So you go to one of these at 4 o'clock on a Friday on your way. I'll take that call on my way home. Cool, I'm a team player, and you get out there and it's a multi-zone and it's low on gas. You may have just ruined your entire weekend. Or what's going to happen is we're going to do the cardinal sin on these things, and we're just going to put a little bit of refrigerant in it to get them by. Right. Well, it's got to get them up and running for the weekend. But now I put refrigerant in a leaky system that I have to recover and get rid of afterwards. So I've just used new virgin refrigerant going into a system that's going to have to be pulled out and mixed with the old refrigerant and recycled. So, and I'm probably going to do that in a warranty situation. I'm going to do it for free because probably my fault the thing leaked, right? If it's still under warranty. And now I've thrown away more material. But what's the other thing? Am I going to do a full 20 a 20 port leak check at 4 o'clock on a Friday? No, you're just not going to do that. What'll happen most of the time in the real world of HVAC service is the technician's going to look at this thing. He's going to see a little bit of oil around one fitting. He's going to put his wrench on it and go, "Oh, that was the problem," and then top it off. Topping it off. You're not supposed to top these units off. You have to, when you install them, you have to put the right amount of refrigerant in it. You need to weigh in the refrigerant for the additional line set, and you need to make a note somewhere. And sometimes these big systems like this can have 18 or 20 pounds of refrigerant in them, which you have to recover it all out and weigh it all back in. So you know it's right. You can't charge these type of systems just with your gauges like you can a single stage. But if they don't leak, they're way better, right? So now, what if I'm going to tell my customer, like, hey, I'm going to put a separate zone, I'm going to put a separate unit in each zone. And it's just a conversation I'm having with them. And then the customer comes home from work and sees this on the back of his house, right? And not a lot of confidence in this. They still left the old one in place, right? But is this any different than putting a big unit out here and having 5 independent zones from a conversational standpoint? Because I've talked to customers that are getting a bid for 5 zones, and I'm like, okay, well, what unit are they putting in? I don't know. Are they putting in more than one? Are they putting in five? Like, this would literally be a better solution, but who's going to want that on their house? Because they're one-to-ones and they'll slow all the way down, and you'll get full modulation in each room, and you'll have independent control. And there's a ton of redundancy in this house. Like, it's very unlikely that all these are going to die at the same time. Don't you love how they left the energy guides on them and everything, and it looks so professional. So that's a lot of our problems. So the advantages of multi-zone, they are flexible for multi-room solutions, but think of them this way. If you've got a house that has 3 bedrooms and it has two needed in a living space, let's put a ducted unit in for the 3 bedrooms, control those all off one unit, and then by the way, I can get a duct into the bathrooms that way, so we can handle that. So I got one little ducted system back there. Probably do it with a 9 or a 12,000 BTU at the most. And then I do a 3 zone with 2 heads, and I got that ducted unit. That's a way better solution than putting 5 of these on here. I've now just eliminated what, 8 refrigerant connections and a whole bunch of refrigerant. So branch boxes reduce line set links, but not always. We installed a system like 4 years ago. There was no other way to do this house than with a ducted system for the upstairs bedrooms, a ducted system for the downstairs, and a wall mount for the basement room. There was no way to do that other than that. And we used one of these with a branch box. but the unit had to go out back because the city was like they were persona non grata on putting a unit on the side of the house. So they're like, it's got to go in the back. It was literally a 50-foot run to the branch box, just right under the spec. And then I had a set going up to one air handler, I had a set going to another air handler, and I had a set going to a wall mount, all off this branch box. That was not a savings of line set links. We did that like 5 years ago when copper was relatively cheap. Now copper is not cheap. We got to think about that too. Um, Less outdoor space needed with these. That's great than putting multiple zones out there. But the disadvantages, like we talked about, way more refrigerant in these units. If there's ever a leak, we've done a lot more damage to the atmosphere, which a lot of people that get heat pumps in their houses are getting it because they're eco-friendly people and they say, "Hey, I want a system that's going to be good for the environment." And then we put one in that has 20 possibilities for leakage, and sometimes those things can leak for years. A company I worked at before I started this company, we had one customer, and every tech that went out there, I didn't sell that one, so I was twice removed. I was just kind of giggling at what was going on about it because it was oversold, it was overbuilt. I would have put a ducted unit in there. They put this 5 zone system in there, and the thing had it leaked down every year after winter. So we know after winter, the pressure in the duct system or the pressure in the refrigerant is way higher going out to the branches. So obviously the leaks are out there somewhere. And it took. I don't know that they ever fixed that problem for sure, but they were going out every year. And the first couple technicians were just topping the thing off. I said, you can't do that. You got to pull the refrigerant out and find the leak and reweigh it in. So the customer bought a really expensive system that was supposed to be great. And every single year they had to go do that. And the company paid for it every year because it was really their deal. And every technician that went out there was just like, oh man, I just topped it off. So um, then there's the capacity penalty we talked about. Can't get units small enough. I'll tell you on load calcs that we're doing up here in the Bay Area, and we have warm areas. I don't want to act like the Bay Area is like the super cool area. Right up the street up here, it gets 109 in the summer for multiple days in a row. So it's not like it's not a little bit more like Inland Empire kind of. But um, we still find that single rooms need very few BTUs. There's no redundancy with this system. Like this thing goes down, I've lost everything. Now it's the same with a ducted system, but there's only one line set in a ducted system, so it's a lot less likely to go down because of capacity issues or anything like that. And definitely more difficult to repair. Like you do not want to deal with one of these and have to think about it the whole weekend. And they're a way more complicated installation. And I got to put these lines everywhere on the outside of the house. This is not the go-to best solution that the people that the manufacturers think it is. Okay. So without a calculation, how do you know what size the system really needs? Or what size what size system the house really needs? These two rooms, this is a house. These two rooms are both 90 square feet. They're the same size rooms. They have the same size windows. One window is facing a different direction. I will tell you this is east and this is south in this particular house. They're both on the same side of the house, but they both have different BTU requirements, which is means if CFMs are going to correlate with the BTUs that we need to deliver, why do I need more conditioning in this room than I need in this room? I'll give you a second to ponder that. This room has 2 outside walls, and the reason I bring this to you this way is when we do our classes and we have guys from the trade in there, a lot of them can't put this together. Because if you haven't been doing load calcs for a long time, you don't recognize certain things that are reality until you've looked at it a bunch of times. And rooms that have 2 walls of outside exposure, like Mother Nature is existing on 2 sides of this room, it's only existing on one side of this room. I need less air in here, which equals less BTUs. And if you look at this small amount of air we need, that is way less than the minimum BTU head size of any system out there. So be careful. Okay. So here's a case study on a multi-zone example. Now this picture and this picture represent the same conversation. So the salesperson came out and told the customer, "Yeah, we're going to put a unit in every room." Okay? This guy just meant a system in every room. This guy, oh, this person said, "We're still going to get a unit in every room." What did the customer hear? I went out on a project recently. We were going up against a guy that was going to put three Mitsubishis in a house, and we sell Quilt, which is a beautiful product. Quilt has the ability to slow way down, by the way, way lower than any other multi-zone units do. It's a really amazing product. But we're going around, and I'm walking around with the customer and my site walk guy, and I'm pointing at the wall and saying, "Yeah, it's going to come up here, it's going to come down here," and the guy says, "What are we even talking about?" And I says, "This is where the line sets are going to have to be installed." And he says, "Well, the other company wasn't going to do that." And I'm like, "Well, if you're going to put a unit in every room, we have to connect tubing to it, and that tubing, you don't want just the tubing on the outside of the wall. We have to cover it up." And so it wasn't that they weren't going to do it. They just never told him they were going to do it. So that guy would have came home from work, and instead of us figuring out exactly how we wanted this and showing the customer and agreeing on how this was going to be done, that guy would have came home from work and saw all this on the side of his house, and his head would explode, right? But so you got to take the time to make sure the customers understand exactly what you're doing, and that conversation can get lost between these two things. So, in this particular application, it's 3 bedrooms. So they're doing a 4 zone multi-zone setup, a 3 ton system. And they could have done in that same house a 1.5 ton ducted system. So they put a 3 ton in, a system that's twice as large as it needs to be. They put two 6,000 BTUs in the smaller bedrooms. The main bedroom got a 9, and the living room kitchen got a 15. The modulation minimum on this is 11.7 versus 5,400 on a 1.5 ton ducted. So if I have a 1.5 ton ducted, it'll reduce the entire load for the entire house down to 5,400 at its lowest point. So once I get the house conditioned, I can keep the house conditioned using a tiny bit of energy. This thing never is going to go below 11.7. That is twice as many watts when we look at it as that is. If we look at it. So when this thing is running in its lowest stage, it's going to use twice as much energy as this does. So what does it mean for the smallest zone running at one time? We got 16 refrigerant connections, 4 condensate connections, possible condensate pumps, and a bunch of drywall work versus just putting a 1.5 ton ducted in. And now it's not lost on me that Eichler built a bunch of houses out there and a bunch of other architects built houses that look like Eichler's with no attic, concrete floor, no place to put anything, windows everywhere. So it even makes it hard to put these units in. Some houses we have to use this technology if we want to do it, but anytime we don't have to, we should not do it. This should be this technology should be used in cases where it's the only thing that we can do in the house. Okay, there's that picture again. It blows my mind. Okay, so here's a multi-zone case study, and I learned this one the hard way. Fortunately, it was a number of years ago. Um, there was 3 units, a big house, 2,000 square feet, 2,100 square feet, all rancher, flat ranch house. The end of the house was the main bedroom suite. It had a master bedroom, a little tiny walk-in closet, and the bedroom was probably 15 by 15. It wasn't huge. And then there was a large open living space with the kitchen, living room, dining room all in one big space. That whole space, if I remember right, was about 12 or 1,300 square feet. The whole big open space. Down at the end, the master bedroom, I would have to think wasn't more than 400 square feet for the bathrooms and everything in there. And on the other end, there was two rather large size, maybe 12 by 12 or 13 by 13 bedrooms and a bathroom right in the middle and a little hallway. When I came in and did the assessment on this house, I looked at it pretty closely. I found that the there was insulation in the walls. They had taken it down to the studs. They were showing me pictures of the remodel. So I took it for granted, which I should never do. Don't ever do that. That the 2 bedrooms on the end were built to the same thermal quality as the rest of the envelope. And they were not. They did not take those down to the studs. They just painted them up. So they didn't put new drywall on, they didn't insulate the outside walls. They did have matching windows, but I said, okay, I made an assumption that the whole house was tight. So I designed it with a 9,000 BTU ducted for the two bedrooms on the end. I'm like, that's going to be plenty for that. And it's got a low modulation rate. I put an 18 in the middle, I believe. I think that's what it says on here. Can't remember. And then a 9 in the master bedroom. Or it might have been a 12 in the middle. We put this in, and literally, I'm telling them all the same things about all these. Oh man, it's gonna be great. The temperatures are gonna be so even. You're gonna love this. It's gonna be great. $35,000 later, however much it was. This is back in 2018, so it was probably about that much money. That would be like a $50,000 job now, probably. Um, the system was just it couldn't maintain. So it was doing all kinds of weird stuff. And we had to use the multi-zone mini split ducted heads are the low static versions. And those require the fans to run continuously to sample the air because they use the thermistor in the air handler. Okay, so that means the fans are running just a tiny bit all the time. And so I didn't realize at that time about this whole low end modulation thing. And so what was happening, one of the things that was happening was those bedrooms were calling for heat way more and they needed warmer air, so higher capacity than the other. And then they were shooting the extra capacity down into the master bedroom suite because it was channel 2 on there. And so the master bedroom where the fan was running and it was getting ancillary heat that was bleeding off from the other zone. And that room was getting way too warm and uncomfortable. So they were artificially turning the thermostat down in that one. It was still delivering heat into the room. And then the other room wasn't keeping up. So what we ended up doing is these people, it was a vacation home for them. So we were able to work on it for like a month. And I told the customer, we're going to fix this for you. I promise. She was not happy. But we got to understand what's going on with it for you first. And so we went out and got a monitoring system, bought this monitoring system, put it in the house. These are all thermometers. And we're looking at supply and return temperatures, like, let's see, that light blue temperature. The spare bedroom's front is the supply temperature here. And you can't see where I'm pointing at my screen. Down here, this is the bedrooms. This up here is the master bedroom, or the spare bedroom return air, but it doesn't matter. You wouldn't want to live in a house that was this uncomfortable. Like I'm getting spreads here all the way from 72 degrees to 62 degrees. This is like a 10-degree differential coming around in this house. And what we found is when that system was running on that one zone on the end, it was causing it to have to go into defrost more for whatever reason. So we called the manufacturer rep out. We called the rep from the distributor out. They both came out and looked at it and they were scratching their head. And they go, well, let's just start changing parts. So they made us change all the boards in the units, change the thermostats, and then change the change the thermostats, and then change the boards in the outdoor unit. So we did all this over a period of time. Didn't get any better. So I sent an email to one of my mentors, because I'm a BPI guy, one of the guys that trained the individual BPI class that I went to, and he said, "Dude, we already studied that in one of our study houses. I wrote a white paper on that. Let me send it over to you." Like literally, we wasted a month. I could have just reached out to him in advance, and basically what he told me was what I just told you. When the refrigerant can't drop down, it bleeds into the other zone and it causes all these weird problems. So the only solution on the house was to do this. We took out the multi-zone and put 3 individual single zones out there. These modulation rate on these smalls are 3,100 per zone. So I can do 3,100 in that bedroom zone instead of maxing it out at 9. And this is an expensive lesson if you think about it. I'm sure it took a little while to sell that other 3 zone. I don't remember the disposition on that, but these units we had to go out and buy 3 outdoor units and then redo the wiring and do all this work to actually fix this problem. But look at what the result was. That's the before and after shot of that one. This is what the result was. This is the temperature coming out of the register on the supply temperature for the loose bedroom side. This is for the tight part of the house. So since those units can now operate independently of each other, those bedrooms can stay warm with 85-degree air that's coming out of its own system, and the rest of the house was be able to maintain the temperature in the house at this steady level of thermal equilibrium with air that's just 7 degrees warmer. So I use this slide right here to sell dual systems in houses. So whenever somebody needs dual zone control, I use this and say, hey, you got two different climate zones. We can't put one system in there unless we can alter the temperature. We can't always do that. So there you go. So two simple systems are the best solution for this. Um, Biggest zoning takeaways. Most common residential applications, it's best to do a zone with two one-on-one ducted units if you can. If you have to do we've got a lot of systems out there that are two zone, multi-zone, and they've got a ducted system for the majority of the house, and maybe they've got a second just wall mount unit in a basement room where it's going to be less critical. Or like that room over the garage that never cools off, or something like that is cool with a multi-zone because I'm taking care of most of the house with one zone and I'm just hitting a spot with the other one. But one-on-ones are always better. You're also going to have less line set with these, less stuff showing on the side of the house, and you're going to get a little bit of a premium out of this if you sell it right. So, and it's all about selling it right. When you're going into a house and you're going, oh, my customer won't pay that. Your customer doesn't pay that because they don't believe your value is there. If you come at them with like, I've seen a lot of companies do it that way, and here are the problems with that. Let me show you what the proper solution is. This is, and then have that. Like, I think you get a copy of these slides. I don't care if you use that little graph, but but show them like two smaller systems are going to give us what are the benefits here? I've got redundancy. If this was one unit goes down, the whole house is down. I've got redundancy. I've got lower modulation rate on each system, and I've got smaller systems that cost less to install. And those systems, when they're running at that ultra low modulation rate, are using a fraction of the watts. So it's going to cost more to install this, but it's going to cost so much less to live with it over the next 20 years that it's going to more than pay for the initial or the additional investment. And if you talk to people and let them understand the benefit and the value that you're bringing, the fact that you're different and bringing a different solution, and it's because you care about what they care about, and the other companies just want to get in and do something quick and they just want to charge you a lot, that's going to give you preference value to that customer. So don't be afraid to take that conversation. Don't stop and don't pre-assume that customers are not willing to pay for something they see the value in. And don't assume a customer's budget is what your budget would be. See, guys, I see we had that at the company I was at before. We had a couple of guys that were like, I won't pay for that. I'm like, how come you're telling me your customers that magically called the same company will only spend $8,000 when I've got these jobs, my average ticket is $18,000? Don't tell me that. It's you, not them. You're preconceiving things. So, um, where are we on time? We got a couple minutes. Any questions?
There are no questions in the chat.
All right.
So I think we can go ahead and move forward with a few announcements about some of the upcoming trainings. And
Yep.
then in the meantime, if anyone in the audience has a question to submit, feel free to put that in the chat room.
Great. Great. Drop your questions in the Q&A box. We'll answer as many as we can if you have any questions that came up out of this. There is some really good trainings coming up from Go Zero. There's an in-person one-day water heating training module. It's central heat pump water heater systems. I believe, Alex, is this the commercial one?
Yeah, so multifamily and commercial. So central heat
Multifamily.
pump water heater systems.
Right. So this is not your typical class for heat pump water heaters in someone's garage. This is to get that knowledge about what's available beyond that. So If even if you don't dabble in that much, you're going to run across it. You'll run across a 5 unit apartment complex with 100-gallon gas water heater for the whole thing that wants to go with a heat pump. If you go to this class, you'll learn about that and know what's available. They're going to show you the products that are available, the application specificity of these things, how you install them, and kind of how you set them up. Amazing class. Then upgrade or optimize the blueprint for electrical panel success. That's coming up on September 15th. I know that's a ways out. We put that one out further, so hopefully it's not right in the middle of summer. And it's a 4 to 5 p.m. webinar. This is a great one if you're telling people, or if you hear other contractors tell customers that they have to get a panel upgrade to put their heat pump in or do whatever work. You need to make sure that the customer understands that they probably didn't do a load calc on them, and that's a default for them because people just want to put panels in. We'll go into how to size the panels and make sure and see what can be done on a specific panel size, because upgrading to a 200 amp panel is just complicated, and it just adds time to the job. And wouldn't you rather have your customer spend the extra $7,000 on fixing their house some other way? Okay. In-person training. Residential load calculations crash course, JDNS, in Ontario on October 1st of 2026. If you've ever wanted to do load calculations, the person that's going to be teaching this class is amazing, and she can give you extra help on the other end as well. This is going to be a deeper dive on how to understand Manual J, which is the room by room load calcs. Manual D, how to actually design the duct system so you guys aren't just out there with a piece of cardboard drawing a bunch of ducts in on the job site. Like, oh, here's my duct map, right? What software did you run that through to make sure any air is going to come out the other end, right? That's not the way this stuff works, folks. So that's going to be really great. And then system sizing through the S, and that is system matching. So you can look at the load calc and see what system it needs to be done, and look at the details on the systems to see if they're actually going to match capacity. Great, great, great content. And then a 2-day comprehensive boot camp on October 5th and 6th. Man, if you don't do any other trainings this year, this one is killer. Everybody that comes to this class is just blown away by all the information that comes through here. This will allow you to get into the cohort program so you can learn even way more. If you're thinking you want to present yourself as an expert in all things heat pumps and understand the rest of the kind of transformation that everything's happening way before it's happening, this is the class for you. This is 2 full days. It is catered. You get some coffee and some water. You got maybe a little bit of snacks or something, but you get nice lunch. And then everybody that goes to this class is blown away by all the information that you get. So this 1 hour that we just shared with you on this one topic of zoning, there's 16 hours of content in this class. People don't come to these classes because they say, "Oh, I got a service call and I missed it." This class is going to increase your sales numbers. This class is going to concentrate on how to sell these machines, how to design them, understand them, talk about them, and then finally, how to convince customers that they need them so your tickets go way up. This 2-day investment in your career could end up with an extra $100,000 a year of sales minimum, and potentially that much in your back pocket if you run with it and actually go out and do it. So potentially $1 million in your company over a year of additional sales, and 100 grand in a pocket of a salesman. Um, just amazing, amazing. We'll teach you how to sell heat pump systems to even the naysayers. So that's a great, great class. Okay. And those classes aren't going to last forever. There's going to be a limited availability on those, and you get some extra perks if you go through that class. Okay. So thank you. You can register with this link or at that link for the upcoming trainings. If you want to scan that QR code, there's a bunch of cool stuff coming out. I would implore you to go to any other classes that are available right now during this transition of our industry. There's a lot of money going into investing into workforce training. That doesn't always happen. When this whole thing calms down on the other end, there's going to be less available. if you want to prepare yourself for the transition that California is going to be going through in the next several years, you need to pick these up while they're at no cost and they're paid for by the utility companies. It's extraordinarily important that you sharpen your saw and that you put the effort and the time into building your career. Because otherwise, 5 years from now, when you're going, oh, I can't miss that service call so I can make $100, or you could be living in a new house with new cars. It's up to you. But if you want to make your life great, these are going to mean way more than just better understanding. These are going to be better quality of life that you will learn. When you learn to sell better, you learn to live better. So I hope I beat that one up a little bit. Scan that QR code. There's tons of classes everywhere, but go to these Go Zero classes. There's a great catalog there. And we are right at time. We're actually a little bit over. If you're still on, thank you. Um, have a great day, and we will talk to you all soon.
Larry, someone had a question in the chat.
Okay,
They're
do
asking
it.
if sometimes one-on-ones are better than zone systems, I mean.
Hmm.
And the one-on-one ducted, are you referring to the slim ducted like the PEAD from Mitsubishi?
Yeah, so the PEADs, even the SVZs and any one to one is better because they all have a lower turn down rate. One set of refrigerant lines, less refrigerant, they slow down further and they're more efficient. Yeah, so the one-on-ones are definitely better and those we install a lot of PEADs.
Okay, great. That was the only question.
All
And
right,
yeah,
fantastic.
looks like we're wrapped up for today. Thank you for everyone for attending.
Thank you everybody.
All
Have a
right.
great day.
Bye-bye.
Bye.